Good morning, class, and welcome to this lesson on Modern 1 Wave-Particle Duality. Today, we will be able to describe the wave-particle duality of nature. So, if you think back to the way this course is kind of structured, um, we spent a good amount of time going over mechanics, right? Mechanics, and basically we were studying the nature of particles. We were studying the nature of particles before. A particle being a very small particle like an electron, or even a thing as big as a car. It doesn't really matter what, but we're talking about things that have discrete values. Okay, we talked about discrete values. So like this thing has, this thing weighs 20 kilograms, and that's it. Um, it's not continuous at all. We moved into thermo, which is the study of heat, and then we started talking about waves. And then our class became very different because waves are a lot different than what mechanics are because waves have a whole different nature. Waves we describe as a continuous stream of energy, okay, or a transfer of energy in that sense. Well, what we have found, basically Einstein and a few other guys have found that on a very small level, when we start getting down to a very small level, actually I'm gonna correct that. I'm gonna correct that. That's not necessarily true at all. Um, at a certain level, waves can act like particles, or waves act like particles, and particles act like waves. And this picture I have to the left is a good example of that. We are firing a beam of electrons at a double slit. And you would think, based off our study of mechanics, these particles should go through this thin double slit and just make two bright spots on the screen where they hit. Because objects in motion stay in motion unless acted on by an outside force. And if there is no outside force pushing them left or right, they should just keep on going straight through and make these two little marks here. But what we find is when they go through a very small slit, these electrons end up getting scattered and diffracted across this whole thing. And this is a diffraction pattern. And the thing that makes this so interesting is that this is a diffraction pattern of electrons. But electrons aren't waves. Electrons are particles. Particles have discrete values. Particles aren't waves, so why are they acting like waves? And so we find that waves act like particles and particles act like waves. So all matter all matter and waves exhibit particle-like behavior and wave-like behavior. And this is most evident for very this is most evident for very small objects, like an electron. Okay, we're not going to see a lot of wave-like behavior in big masses like a ball or something like that, but it does exist. But it's just not evident. But so this is going to be evident in very very small objects like an electron, like light, things that are very 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 small. And so just to give you a preview, one of the things we're going to find is we're going to find the momentum of a photon. And we'll talk about what that means in a second. But we're going to find the momentum of a photon, or we're going to find the momentum of light. Now, you don't think of light as having momentum, but it does. Um, and so that's just an example of something that's going to come up. But so this is what I'm talking about. We're going to start talking about mechanics-based things with waves. And then we're going to talk about wave-based things with mechanics or particles.